Hello everyone, today we are going to talk about how to make an on-chain NFT music. Now this is an on-chain NFT music that I've made myself. It's called 12-note Ringtones. And I've minted one just for the sample. This is totally 100% on-chain. It's using base64 to load. Now if you look at the contract address, go over the contract, head over to the read contract and token URI. Okay, this is a lot of data. This is the metadata. Okay, so we are gonna copy this. This is a lot of data though. Okay, and we got this. This is the metadata. This is the name, description, the image, which is this image. Okay, this is the description and this is the name. And this is the animation URL, which is the MP3. And that's the ringtone. We just copy this, copy everything. Okay, so this is completely 100% on-chain. Anyways, this is 20 Matic per mint. Feel free to mint. Okay, so why is it only 3 seconds? Now you can actually play a full length of an audio or even any music, but some browsers are limited. Like for example, I think Google Chrome is limited to this. For example, over here, Google Chrome is maximum 2 MB, which is 2000 characters. And Mozilla can do like 65,000. Let's try around 2 minutes of a music audio. Okay, so this is around 2 minutes and a half, I think. So it's taking quite a long time to encode to base 64. Okay, it's actually taking longer than 30 seconds. Okay, so you can copy everything here. And then, okay, wait, it's possible to do everything. Is it? I don't think so. It's written 255, but let's see how long. It plays for 9 seconds. Okay. Let's try on Mozilla. I think it works. Let's try. Yes, it works. And it crashed. But it works. I think my computer is just... my PC is just not good enough for this. But it works until the end. Now first of all, I'll just show you the contract. Okay, so this is the contract that I made. It's called 12-note ringtones.sol. Okay, so I put this strings, which is the notes. This is 1 octave. Okay, and I put this as an array, and then I concatenate them together with a random. Okay, so that's basically it. And this is how I made the base notes. I tried looking for some notes online, but they have some white noises and I didn't like it. So I made my own notes using JavaScript, using this audio context. This is something that I copied from this developer.mozilla.org. This one. This is the code that I copied. And I modified them a little bit. So it looks like this. Make wave. And then there's a 250 millisecond notes. and you can just download it. And then later on, you can just use Audacity to make the file smaller, because I'll tell you the reason why a bit later after this. And you can just change the frequencies over here depending on what you want. I got the frequencies from here, for example, octave 4, C, D, E, F, G, A, B. Okay, so just now was B, right? Just change them. You can just change the frequencies over here. And after that, turn the notes into base 64, just like this. And then paste those base 64 strings over here in the smart contract. Okay, now I'll talk about the smart contract. First of all, you need this base64.sol. I took this from Breck Defos, which is the author. It has the encode, base64 function, and decode. Why do I need a decode? I will tell you later in a bit. Okay, so this is the strings. You can change this octave by all you want. And this is the array. So go ahead and take a look at the smart contract. And this is the main function. Okay, so basically this is the name, ringtone, our tone, number, supply +1, and make it a string. And this is the description. It's following the struct, name, description, and score. Now this is the score. Okay, so back to why do I need the decode and encode? It's because if you want to combine multiple base64 audios, you need to decode them first into the bytes, and then you need to concatenate them together and then encode them again into base64. So that's basically it. This is the random function to determine which notes that I'm using for the scores. Okay, so there are 12. This is my random number function. And then build image for the ringtone image just now. If I don't have this, the one in Opensea, this one will give like a no image written over there. So I don't think that looks good. Which is why I added this build image function. It's a simple one. White background and a black font. This is the token URI over here, and that's basically it. It's a very simple smart contract. Now, why is it only 12 notes that I make over here? It's because of the limitations of the smart contract. Now, initially, I want to make it at least 3 seconds long or so. But when I try to put more strings, like more octave over here, obviously 1 octave is not good enough for making a ringtones. At least 2 octave is better, right? But smart contracts have a 24K, around 24K, a bit more, like I think around 24.3K bytes limit. So if you go over that limit, it's not possible to deploy the smart contract. I think they mentioned it's to avoid DDoS. And why didn't I make more than 12 nodes? That's because of the limitation on calling function. There's a guess limit per function when you do like, for example, when you go to the polygon scan, the write contract over here, if you mint this, for example, there's like around 12 million guess limit, if I'm not mistaken, for the call function. And also inside a function, there is a limit for the variables used. So there's a lot of limitations for smart contract right now. I've tried that 12 is like almost the limit. Yes, so I use 12. Now there's something that I haven't tried, which is using a library to put all the nodes. So for example, this one takes a lot of space. Okay, this takes like around, let's see. Okay, let's try. This takes like around, for example, let's try copying this whole thing. And as you can see, this is around 800 bytes and 860 bytes and times 7, which is already around 6000 bytes. And that's not including all these functions, which is, if I haven't tried it myself, because during this project I just wanted to try what's the limitations, and I will be trying that again in another project to use the library for all this data. So I just call them when I want to. But even with the 24k bytes limit solved, I don't think this calling function limit can be solved. But so at least within the 12 nodes, there will be more than 1 octave. So it's still around 3 seconds at most, but more variety for the nodes. Okay, so I hope that helps as an inspiration for you to make more on-chain NFT projects in the future. And thanks for watching. I'll be putting all the necessary links down in the description, and have fun coding.